For over a decade, if a developer ran into a problem, they went to a public programming forum to ask for help. Millions of people learned to code by reading the answers left behind. But recently, those archives have gone quiet. This graph plots Stack Overflow questions over 10 years. A sharp structural break starts in late 2022, leading to a steady collapse. From its peak to December 2025, new questions dropped by 78%. That knowledge didn't disappear. The questions are still being asked, but they have migrated off the public web and into private, on-demand chats with AI models. Curious, what is driving that migration is the sheer bottom-falling-out cheapness of generating answers privately using open-weight AI models. This chart compares the price of generating intelligence. The frontier tier Kimi K3 costs just $3 per million input tokens. Comparing it to proprietary US models reveals a massive delta. Open models deliver top-tier output at a fraction of the cost. Generating raw intelligence is no longer a public good painstakingly built by volunteers. It is an impossibly cheap private commodity that anyone can generate on demand. This wave of cheap, highly capable open models is forcing established tech titans to rethink, and in some cases abandon, their premium paywalls entirely. In mid-July, Anthropic announced a sudden reversal on how it would sell Claude Fable 5, its most capable model. They originally planned to pull it from their subscription accounts entirely, but abruptly decided to keep it in their Max and Team premium tiers. The company faced a harsh market reality. Consumers will not pay $100 or $200 a month for a premium subscription if it intentionally excludes the company's absolute best technology. Anthropic was boxed in by the competition. The decision to keep Fable 5 in paid plans came just 2 days after a Chinese open-weight model reached that exact same frontier capability tier. Raw computational power and premium intelligence cannot be hoarded behind a high-priced wall anymore. The market is forcing a severe deflation in the perceived value of an AI's raw output. This deflation is driven by a shift in how these models are run. Surgical efficiency in software is outmaneuvering the sheer brute force of massive, expensive server farms. Developers are using new hobbyist tools, like a project called AirLLM, to run massive 70 billion parameter models on standard $200 consumer graphics cards. This structural diagram shows how they pull it off. Instead of loading the entire massive neural network into memory at once, the software only holds one single layer in memory at any given time, moving sequentially down the stack to process the data. But while hardware efficiency is thriving, applying that same brute force logic to software behavior is backfiring. We see this in what researchers are calling the persistence paradox. In a recent benchmark test, developers evaluated a new goal feature that instructed top AI models to stubbornly pursue a solution on a highly complex network design puzzle with countless possible solutions. When instructed to be persistent and stay on target, the models actually produced lower average scores than when they were run in their standard plain baseline modes. In a true optimization problem, locking on to a bad strategy early on and trying harder only amplifies the mistake. Giving an AI more compute and telling it to relentlessly pursue a goal fails if the underlying logic is flawed. We are watching this tension between generating answers and proving them play out in professional mathematics, specifically in convex optimization. In a span of days, researchers used GPT 5.6 to establish a lower bound proof for a 30-year-old math problem, confirming that an old method for solving it was already the fastest possible approach. It generated the work in hours. But there is a massive caveat that has split mathematicians. The AI's proof has not been formally verified in checking tools, and it hasn't passed peer review. It is plausible, but it isn't officially true yet. This verification bottleneck extends straight into software engineering. A recent 12-week case study analyzed what happens when autonomous AI agents are left to govern their own software generation. The sheer scale of what the AI built was staggering. The agents autonomously pumped out 420,000 lines of production code. But the study revealed a critical bottleneck. Generating the code was cheap and instant. The massive, unavoidable cost was the human engineering judgment required to review, govern, and ultimately trust that the code actually worked. A machine can construct a massive digital architecture in a fraction of a second, but it is entirely blind to whether that architecture will hold weight. Only a human can verify its integrity. You might think the solution is to just build another AI model to verify the first one. We already know that fails, and we can prove it by looking at AI text detection. This diagnostic scatterplot maps the performance of AI detectors. When a language model is prompted to mimic a specific human author, the sweeping scanners miss between 13 and 26% of the disguised text, letting those anomalies slip right past the boundary line. Those are false negatives. The detector says the text is human when it isn't. When a quarter of disguised writing slips through, you can no longer rely on that system to uphold academic or professional integrity. High finance and enterprise investors see this verification crisis clearly, and they are moving massive amounts of capital exactly where you would expect. Databricks, an enterprise data company, recently signed a term sheet valuing it at $188 billion. That is a $54 billion jump in just a few months, making it one of the most valuable private firms on the planet. Databricks does not build frontier AI models. They build the underlying databases, the infrastructure, and the governance tools that corporations use to manage their data and verify that their AI outputs are actually correct. We are crossing a strange threshold. As the raw cost of generating text, math, and code rapidly approaches zero, the generation itself loses its premium. The most expensive, valuable commodity left is the human infrastructure required to govern the truth.